All right, so we talked already a little bit about common logarithms. Common logarithm has a base of 10, and you can solve common logarithms on your calculator. But if the problem is not in base 10, there's another thing you can do called the change of base formula. It comes in handy when they're really weird numbers. Like you just did your quiz, your little mid-chapter quiz here, and some of those, I think you guys, some of them were easy for you to solve, like if it said log base 5 of 25. Did you know the answer for something like that? Yeah, the answer is 2. 5 to the second power makes 25. So that's something easy. But there's some logarithms that are really weird. What if I asked you to find log base 5 of 17? Would you have any idea what to do on that? So that's where this new thing called a change of base formula is going to come in handy. When they ask you something weird, like, wait, like 5 to what power gives me something weird like 17? Like, what? That's weird. So we're going to learn this thing called change of base formula to deal with those. It's the same on this one I'm showing here. Log base 3 of 8. It's asking like 3 to what power gives me 8? Well, so you have a close guess. Adam already held up 2 fingers. What's 3 squared? Go ahead. What do you think? What's 3 squared? 9. So it's close to 8, but it's not 8, is it? So you're thinking it's... Yeah, it has to be exact. So since it's weird, there really isn't a nice number that you can do 3 to some nice whole number to get 8. That doesn't work. So what you do is called a change of base formula. You go log of 8, you do the big number, over log of 3. And then you grab a calculator and type that in, log of 8 divided by log 3. Because on the calculator, there's a log key, a common log key. So I just type log of 8, close the parentheses, divided by log 3. So this time you have to use a calculator. Because there's not a nice thing that comes out 3 to some nice number, whole number. So you type that in, and it's 1.89. So Adamari, your guess of 2 was really close. That was awesome. Yep. Answer is 1.89. See, it has to be a little less than 2 because 3 squared is 9. So you had a good thinking on that. Good guess because you're like, well, 3 squared is 9, so it has to be close to that. So does that make sense? These are weird ones that you can't just nicely solve in your head. There's no like 3 to a nice whole number that gives you 8. Yeah, these are going to be decimal answers. So how would I set up this one?
Log 24 divided by log 6.
Awesome. So it's called a change of base formula, and then you just use your calculator to do it. Log 24 divided by log 6. Yep, so you just have to use your calculator. Log 24, close your parentheses around the 24, then divided by log 6. What do you think the answer is this time?
1.77.
Ooh, okay. 1.77, that's good. So yeah, it's like 1.7737. So yeah, because it's not 6. If you think of it like 6 to the first power is 6. 6 to the second power is already 36. Like if you did 6 squared, that's 36. See, that's way too big. You're trying to think of 6 to what power gives you about 24. So it's a decimal. So it's called a change of base formula. It works pretty nicely just to deal with these weird ones. So those should be pretty easy. It also works for natural log questions because we've common log was base 10. It would also work for natural log. Like if it said find ln of, well, we don't even really need it for that, do we? Because if it just said ln, yeah, we wouldn't even need it. But you could just use the ln key. Yeah, I was thinking, wait, do I have to explain it anymore? But yeah, like if they just tell you, like, find natural log of 6, you can just grab your calculator and type in natural log of 6. It's just use a calculator. Because natural log is base e. So it's asking e to what power gives you 6. And that e is a number like pi, like we've talked about. So yeah, you just type in ln of 6. And you just type it on your calculator. 1.79. 1.79. It means like the number e, which is 2.7. If you took it to this power, you would get 6. It's kind of weird stuff, I know. Yeah, if it says find natural log of something, you can just use a calculator. All right, now let's move on to properties. So properties of exponents we've seen before, product properties, quotient properties, and the properties of exponents were used to develop these properties of logarithms. So the first one is called a product property, and it says log base x of a plus log base x of b. So see how it's kind of like two logarithms separated by a plus sign? This logarithm plus this logarithm. They're trying to show you how you could put it together. You can just say it's the same as logarithm of base x still of a times b. See, it has a times b together. So they say when you put it together, when you put these two logarithms together into one, they say you're condensing it. You're putting it together, you're condensing it. And if you separate it into two things, they say that you're expanding it. And we're going to be going like both ways on this. Some problems are going to ask you to expand it, and some problems are going to ask you to condense it. So it's kind of good to say like this equal sign. I'll put like an arrow, like it can go both ways. We should talk about that. It can go both ways. You could take some addition problem and put it together into one, or you could take something that's multiplying two things, like something times something, and break it apart into an addition. You can expand it. So these rules do go both ways. Same thing here. This one has a subtraction in here. Subtraction. This logarithm base x of a minus logarithm base x of b equals logarithm base x a divided by b. See how a minus is, now it's a dividing over here. A divided by b. And again, this can go either way. So I like to make this equal sign like an arrow. I could change it from this way to this way, or I could change it from a fraction problem like this into a subtraction problem. So again, it's the same as this is condensed, like put together. This side's called condensed, and this side's expanded into two things. So it's the same. This is expanded. You can write expanded or expand, I don't know. And this is the condensed side. Same thing again. And we're going to try these rules down below. We'll try some. It's just kind of showing you them first, these properties. Ooh, this one's kind of interesting. This one's a power property. This one, look where the P moves. The letter P, we put that for power to stand for power property. It's like an exponent. If you see a number in front of a logarithm, you can like bring it back in the, you can move it all the way back here so it's m to this p power. See where the p moved? This is a power, or you can put it back over there. So again, this is same thing, right? Am I going to say it or is it backwards? This is considered condensed, or no?
Yeah.
Or is this one considered condensed? I want to make sure I don't say it.
Yeah.
I don't want to say it wrong.
Because that's all underneath quadratical. Or not.
Yeah, yeah, this one's called condensed. Yeah, I was worried I was going to like had it backwards on this one.
No.
This one's condensed because it doesn't have something in front. Yeah, and this one's expanded. I was seeing if I had them all in the same order. Because they go both ways. Yeah, like if I flip it around or something. Okay, so these properties up above, you can use them to do this expanding or condensing problems, and they work either way, like we were saying. So the problem right here says log 10x. So isn't that the same? I'll try to write it step by step. Isn't that the same as log of 10 times x? Like kind of just accentuate. Isn't it 10 times x when it says 10x? So you're right, it's a product. It's like timesing something. So it's a product. So we could write product property. That's good. It's the product property. And they're saying to expand it. So we're like right now what we have is something that's condensed, and they're asking us to expand it and get something like this. Like break it apart, expand it. So if something's condensed, a times b, see how they break it into log a plus log b? So what do you think? How's this going to go? Log 10 plus log x. Good. That's it. So it's not that hard. That's it. It's like learning a rule, learning how they work. It's a property.
And that's just the whole thing.
Yep, that's the answer. So it's kind of takes a little getting used to though. It takes a little getting used to. Okay, this next one. It says ln, like this one said log, but these properties work no matter if it says log or ln. The ln means natural log. It's the same, but you use the property the same way. Okay, so this has a 6 here. And it's just kind of like the same as up here. It's like this power property up above. Okay, so it's like this power property. And sometimes they might have more than one property involved. There might be more than one property involved. Is there anything else? Yeah, this 2 here, isn't that 2 times x to the 6th? So I think it's a product also. Product property. Product and power property. There's both there. There's both going on. So I'm going to write ln, natural log. So just to kind of accentuate it, it's 2 times x to the 6th. And it's kind of important to notice that the 6th power, it was just on the x. The 6th power, it wasn't 2 to the 6th power. So it's kind of important to notice that. It's just x. If they wanted the whole thing to the 6th power, they would have had parentheses around it. So you want to break it apart like this. So let's do the product property first. What do you do when it's times? How do we break this apart? Yeah. Good job. Okay, now we have this power here still. Oops, that smeared. That was a 6. Wrote on it too soon. That highlighter just smeared it. Okay, now what do you do with this? Yeah, it's weird. You just bring it over here. So it's ln of 2, natural log 2, plus 6, natural log x. Smeared it. Oh well. Yeah, the 6 just goes in front. 6 times natural log x.
So whenever you have an exponent, you just move it to the front.
Okay, next one. Next one is a fraction. So I think it's that quotient rule. Quotient property. And then I also see those powers again. So it's going to have powers in it too, the power property also. Quotient and power properties. See, there's more than one thing going on here. So let's first start with, like it says, it's a dividing. Okay, so log base 3. Okay, what do you think? If it's a fraction, could you break that apart?
Yeah.
What do you think we should write?
3x
X to the 4th, yep.
minus
Minus log base 3 of, 3y to the 3rd. Ooh, there might even be another property going on here too. There's a lot going on here. There was a quotient because it's a fraction. That quotient means dividing. There's a power because I see like 4th power on things. And then even this one has a product in it too. There's a product property because you have like 3 times y there. So there's a lot going on this one. So I think we might need maybe some parentheses around this one when we keep breaking it up, because you want it to be like divided by that whole thing. Ooh, there's a lot going on here. What about the beginning one? We're almost done with the beginning one.
The 4 in the front.
Yeah, you could put the 4 in the front. So you have 4 log base 3 of x minus, okay, this one's the tough one. So like I was saying, there's a product here, so we need to break that apart too before we do the power.
log 3 plus log 3y.
Yeah, so log base 3 of 3, it's like 3 times this, so it's 3, log base 3 of 3 plus log base 3 of y to the 3rd. That's a lot going on, and then finally this 3 can come in front of this. That 3rd power can go in front of that. That's a lot going on this one, so I think we about got it though. 4 log base 3 of x minus log base 3 of 3 plus log, oh, I need a 3 in front, 3 log base 3 of y. Yeah, I'm trying to put the 3 in front. Ooh, there's actually even one more thing I just remembered. Sometimes when you do these things, then you can even solve a piece.
3 plus 3.
Did you know that, like, maybe you see, there's an answer to this. They do that sometimes. I actually sometimes would just leave it like that, but
You're so easy to.
this is kind of easy to see. Like, do you guys know what 3 to what power gives you 3?
1.
So you could replace this with the number 1. So it'd say 1 plus that. That's the last thing. Actually, on a test, if they got it to that far, I'd give it to them. Because, yeah, this, sometimes you're like, oh, I forgot to solve. Yeah, like you can actually solve that and say this is 1. 1 plus that. But, yeah, it's kind of depends on if your teacher's, I could see putting in the directions, like solve if you can or something. Like, yeah, so finally it'd be 4 log base 3 of x minus 1 plus that 3 log base 3 of y. I know sometimes at the end, once you start breaking these apart, you're like, oh, I could just solve that. That's the tricky one, though. Yeah, honestly, if you guys got it all the way down to that far, I'd give it to you. Those are tough. But yeah, that does equal 1. 3 to the 1st power equals 3, so that's just a 1. Yep, that's a tricky one. Okay, now condensing. Condensing is putting it back together, going the other way. So I would say look for powers first, look for the power property first, and then the quotient and the product rules. It's usually how it kind of works. Do you see any powers that you could move?
3.
Yeah, this 3 here, you could like put it back up here so it's like x to the 3rd power up there. See? It's kind of weird, isn't it? I kind of like these. It's just like manipulating something, changing it into a different form. So we have log base 2 of 3 plus log base 2 of 8 plus log base 2 of x to the 3rd power now. So you just make it back as x to the 3rd power. All right, now these are additions, so what do you think we could do now?
Add 3 and 8.
Oops, it's going to make an announcement.
Pardon this interruption. Just a quick heads up. Dr. Bronick had sent an email out just a little bit ago.
I saw it already.
Extra vaccines for appointments for tomorrow. They are first come, first serve. So if you are still wanting to get your vaccine, please find your email and log into that and get signed up. Thank you.
Okay, so it is an addition problem. It says plus here. But if you look at the rule, do we actually add the stuff?
No.
What do you do with the things that were in
Let's smush it together.
you put it together and it's actually multiply. It's called a product property. Yeah, you actually multiply them. So the 3 and the 8, you're actually going to multiply them together. It's actually going to be 3 times 8 times x to the third. And you can actually times 3 and 8 together. What do you think final answer is then? What's 3 times 8?
24.
So it's 24x to the third. Yeah, so addition, you times, when you put it together, you times. It's weird, but it's based on the rules of exponents. Like when you multiply, you add exponents. Remember that? When you multiply like x to the second times x to the third, you add the exponents. That's why it's like times and multiply go to, times and add go together. Divide and subtract go together. Okay, one more of these. Okay, so again, I would probably look for the power property first. Like over here, I see a 2 in front of this, so I'd put that back over here. So I have log base 4 or base 5 of 4x minus log base 5 of 5 squared. See that 2? I can put it back 5 squared. Ooh, what's 5 squared? Yeah, we could actually put the answer for that then. Good job. So log base 5 of 25. Yeah, 5 squared, that's 25. You can actually do that. All right, now this is a subtraction one, and we're trying to put it back together. So what do you do? Yeah, so it's going to say log base 5 still. 4x over 25. See? 4x over 25. And then there's a few where on the back where you have to kind of manipulate something. They actually sometimes give you answers to use. Like they say log base 2 of 5 equals this decimal. Log base 2 of 5 equals this of 12 equals this decimal. Use this information to evaluate your logarithms below. Well, try to use my highlighter here to highlight these numbers. 5, 12. Now this says 60. What you need to do is use the given information at the top to figure this out. You got their idea, yeah. Like 60, could you break 60 apart? Could you divide it by 5? Yeah, 5 times 12 is 60. Good job, you got the right idea. Log base 2. 5 times 12 is 60. So we were just learning these properties, and when it's times, you actually add these together. See, when it's times, it breaks apart into an addition of 2 logs. So now it tells you at the top what log base 2 of 5 is. They tell you the decimal to use for that. They tell you the answer for that. And they tell you the answer for log base 2 of 12, so you're just going to have to add those answers together. That's right. So it was 2.322 plus 3.585. We could just leave it to 3 decimal places because they gave each number in 3 decimals. So what do you get? 5.907. Okay, there we go. Well, it gave it 3 decimals in each one, so leave it in 3 decimals. Maybe your calculator settings need to get fixed. We could fix it. Like if your calculator just said 6, it rounded it. We need to fix the decimal place thing. So yeah, these you have to look at the number they give you and see if 5s or 12s go into it. Because they're just based off of the given information. Does that make sense? So you see this number in the next one, 144. Does 5 go into 144? What about 12? Does that go into 144? Yeah, good. So you just want to rewrite it as something with having to do with 12 then. Yeah, 144, isn't that 12 times 12? Good job. Okay, so the problem right now, I have log base 2. So I have 1 over, it's like we're saying it's like 12 squared. 144 is like 12 squared. So it's a fraction 1, a quotient. So you should rewrite it log base 2 of 1 minus, because quotient was the subtraction 1, log base 2 of 12 squared. Does that make sense? When it's a fraction, it's a minus problem, just like the... Okay, then we have this 12 squared. You want to pull that, that's a power property. You want to pull that in front. So now we have log base 2 of 1 minus 2 log base 2 of 12. Now up above, don't they tell you how much this equals? They tell us that's 3.585. So I'm just going to have to like times that by 2 here. It had a 2 times that. Ooh, what's log base 2 of 1? Try to type on your calculator log of 1. See what it tells you if you forgot.
0.
Yeah. Anytime it's log of 1, ln of 1, log of 1, it's always 0. So then we just do the math and figure that one out, and we're done with that one. 3.585. So this one came out negative 7.17 is what I got. Just did it on my calculator. And it's the same on the last one. I mean, I can go through it quickly. Same type of thing. You have to think about how 12s and 5s that they gave you at the top are related to the numbers they give you in yours. And I think most you see are seeing how this works. Doesn't 5 go into 125? If you figure it out, it's 5 to the 3rd power makes 125. 5 times 5 times 5 makes 125. So it'd be log base 2 of 12 minus log base 2 of 5 to the 3rd. So see, the fractions turn into subtraction problems. Quotient rule. And then again, you would bring this power over here. So then we have log base 2 of 12 minus 3 log base 2 of 5. Up above, they tell you decimals for these. They tell you that log base 2 of 12 is 3.585. And then they tell you log base 2 of 5 is 2.322. So then you just plug in those values and you'll get an answer off the calculator. I got negative 3.381 just by typing that in a calculator. If you think I did it wrong, let me know, but I think I did it right. You know, sometimes we make mistakes too, so. Yeah, so it's just getting used to these properties, how to expand things, condense things. We do have an assignment, but we tried to keep it. It's one page, you know, it's not like front and back, like 30 problems or something. We tried to make it so it's not super long. I know. Try to keep it reasonable. Yeah. Yeah, you got this. Yep, okay. Yep, that's good.
Nope, not that one.
Let's see. I thought. Okay, what's up? Yeah. Lots of log. Is this one? Yep. How is that related to how could you get that number by using yeah, how do you get to
All by reflection across the line.
so how do you
We are building on
yeah, so right, 2, so you're gonna do like 6 divided by 3. And 6 divided by 10 is the log with subtract.
Yeah.
Yeah, so you know it's kind of weird though. Because you're saying you're gonna do like a 6 divided by 3 makes 2. Log with yeah. Yeah. Yeah, I think it's really nice. Okay. Okay. I just want to think about. Yeah.